Okay, so we will continue solving example about internally unstable beams. So, internally unstable beams are beams with internal connections. Katulad nito, mayroon tayong internal connection ng point D at saka sa point E ng beam. So, we call this a continuous beam. Okay, so, check na natin kaagad yung determinacy. That is the first step. We check the determinacy. So, we count the number of support reactions component. No? So, ito yung R natin. So, that is equal to 1 kapag roller. No? Kapag ka naman fix, yan ay 3. Okay, so dalawa yung roller natin, so dalawa na yan. So dito naman 3. So all in all, we have 5 support reactions components, AY, CY, FY, FX, and MF. Okay, so those are the support reactions. No? So 5 lahat. Ito namang isubsi natin the equation of condition, that is 1 for every hinge connection. So mayroon tayong dalawa, so ibig sabihin that is equal to 2. So if we now replace the value of R, this is equal to 5, then 3, the equations of static equilibrium, then E sub C is equal to 2, then that is 5 equal to 3 plus 2, or 5 is equal to 5, that is externally stable and statically determinate beam. So it means that the equations of static equilibrium is enough to solve for the support reactions of the beam. So we will now solve the support reactions using the equations of static equilibrium. Pero pag binasa nyo itong paragraph na ito guys, hindi natin pwedeng isolve kaagad itong support reaction na yan using the equations of static equilibrium. Bakit? Mayroon kasi tayong 5 na unknown. 3 lang yung equations of static equilibrium natin. So anong technique? Kailangan natin siyang i-isolate dito sa location ng internal hinge at D and E. So i-isolate natin dito sa D and E. We will draw separately the free body diagram of the beam. So, separate natin yung ABCD dun sa DE at saka dun sa EF. Okay, so yun ang ginawa natin dito sa free body diagram na ito. Okay, so ang technique, alam natin, magsisimula tayong mag-solve ng unknown support reactions dun sa free body diagram na mayroong pinakakaunti ang unknown. So, least number of unknown. Ika nga, no? So, dito guys, ang nansin, na itong dy at saka ey was assumed upward reaction forces. Okay? Dahil sa alam natin, yung resultant, that is the area of the uniform load. Okay? So, that is downward. Kaya ina-assume natin na ang dy at saka ey ay upward. Since dito tayo magsisimula sa pag-solve ng unknown forces. Dahil ito nga, yung free body diagram na may least number of unknown. So, pag pinansin natin itong nandito sa itong free body diagram ABCD, no? So, mas marami ang unknown nito compare dito. At saka ito din, guys, ano? So, pag dito 1 2 3 4 5, 1 2 3 4 5. So, tig-5 sila ng unknown compare dito na 4 lang. Dito tayo magsisimula. Kaya dito tayo mag-a-assume ng unang direction ng mga forces, katulad nitong dy at saka ey. So, pansinin din ninyo na pagdating dito sa free body diagram na ito, yung dy downward siya. Samantalang dito is upward. So, ano ibig sabihin nun? So, yun yung tinatawag nating action and reaction are equal forces but opposite in direction. So, pansinin yung ey, ganun din. Upward siya dito, downward din siya dun sa kabila. Okay? So, kasi nga, kapag hindi natin magawa yun, maaaring yun ang maging dahilan para malito tayo sa calculation. At magiging mahirap ang paghahanap ng mali dun sa nagawa natin. Okay, so sana matandaan nyo yun. So we will now start applying equations of static equilibrium dito sa beam na ito, segment DE as our free body diagram. So we will apply summation moment at point D is equal to 0. So nandito tayo sa point D, clockwise yung 150 with respect to point D, at counterclockwise naman yung EY with respect to point D. So itong 150 is positive, then yung EY is negative. So from this equation, masosolve natin ang EY that is equal to 75 kN. So assume direction was incorrect. Bakit? Kasi positive yung 75, no? So, ibig sabihin, tama yung assumption natin, upward yung EY. Kapag negative yan, ibig sabihin yung EY is downward. Okay, so we will apply summation moment at point A is equal to 0. Clockwise moment, positive pa rin. So, dy is clockwise, positive yan. Yung 150 naman ang negative kasi counterclockwise ang ikot niya with respect to point A. So, from this equation, no? Kuha natin ang dy, that is also equal to 75 kN. Linagyan ko din ito ng sign na upward. Kasi nga, positive yung lumabas dito sa 75 kN na ito. So, ibig sabihin, tama yung assumption natin. That is an upward force. Okay, so we move on free body diagram EF, or pwede rin naman dito sa ABCD na. No? So, alam kasi natin ang dy is equal to 75. Alam din natin EY is 75 din. So, since there's no horizontal load applied on the beam, ito kasing AX at saka DX na 0, kaya dalawa na lang ang pwedeng unknown natin dito sa free body diagram ABCD. Ganun din dito sa free body diagram EF. Dalawa na lang ang unknown MF and FY, kasi yung EY na solve na natin, that is equal to 75 kN from free body diagram DE. Okay, so we move on free body diagram EF. We will apply summation forces vertical. So pag nag-apply tayo ng summation forces vertical dito, mayroon tayong isang upward force yung Fy, yung 150 downward and yung EY downward din. Okay, so pag tinignan na natin yung equation natin, ito yun. So Fy is positive, EY is downward, then 150 is downward din. So yung EY natin, since that is equal to 75, replace lang natin yung value. And from this equation, we can solve for Fy, that is equal to 225 kN. So assume direction was correct kasi positive yung lumabas na sagot natin. That is an upward support reaction. Okay, so next, we'll apply summation moment at E dito sa point E nito. That is to solve for MF. No? Ito naman ang sinusolve natin, MF. So, with respect to point E, guys, no? So, itong 150 kN na ito will rotate in a clockwise manner with respect to point E. And the moment arm is equal to 6 divided by 2. Dahil alam natin na itong resultant na ito, it is acting at the centroid of this uniformly distributed load. Okay, so ganun ang resultant. It will act at the centroid. Kung ano man yung configuration ng load na yan, dun sa gitna niya, nandoon yung resultant. So yung moment arm natin is 3 meters. Then Fy, that is a counterclockwise moment with respect to point E. And the moment arm is equal to 6 meters. So, itong MF naman na ito, ina-assume natin na clockwise. Ngayon, pag nag-negative yung sagot natin after we perform the operation, ibig sabihin, mali itong assumption natin na clockwise yung MF. Okay, so, check na natin yung equation natin. So, summation moment at A, 150 times 3, that is positive, clockwise yan. Pag tinignan natin sa free body diagram, then negative yung Fy times 6, counterclockwise naman ito. Then MF, ito yung clockwise rin, no? So, ina-assume natin na clockwise ang MF dito sa free body diagram natin dito. Okay, so, we replace the value of Fy, that is equal to 225 kN, no? So, masolve na natin yung MF dito sa equation na ito. And that is equal to 900 kN meter. So, tama yung assumption natin. Bakit? Positive yung lumabas na sagot. So, ibig sabihin, that is a clockwise moment. So, it will bend the beam at point F in a downward direction. No? So, ito yung ibig sabihin ng clockwise moment dyan. Okay, so we can apply equations of static equilibrium to segment ABCD or free body diagram ABCD, no? To solve for the remaining support reactions AY and CY. So we can apply summation moment at A. Okay, so the only unknown will be CY. Bakit? Meron na tayong DY. That is equal to 75 kN. Ito, na-solve na natin dito sa free body diagram DE. Okay, so we apply summation moment at point A. So yung 200, that is a clockwise moment with respect to point A. Yung 150, that is clockwise moment din. Yung CY counterclockwise moment, then DY is clockwise moment pa rin. So isa lang ang negative yung CY. Counterclockwise kasi siya with respect to point A. So pag tinignan na natin itong summation moment at A natin, so mati-check natin ito. Parehong positive yung tatlo, itong CY lang ang negative. Okay, so if we replace the value of dy, that is equal to 75. Solve na natin ito sa nauna nating equations, no? Equation dun sa free body diagram DE, no? So pag replace na natin yan, kuha na natin ang CY, no? So from that equation, that is equal to 475 kN. Tama pa rin yung assumption natin. That is an upward support reaction. Bakit? Because 475 kN came out to be positive. Then we will apply summation moment at t is equal to 0. So dito naman tayo mag-apply ng summation moment sa point D. So pag dito tayo nag-apply, CY clockwise yung moment natin, yung AY clockwise din, then 200 counterclockwise, then 150 counterclockwise with respect to point D. So mayroon tayong apat na component ng forces, AY, CY, 200, and 150, where AY and CY will rotate in a clockwise manner with respect to point D. So, tignan na natin yung ating summation moment dito. So, dalawa ang positive, AY and CY. Okay, so we have already solved for CY. Ito yung 475 kN. Pag re-replace natin yung value niyan, AY na lang ang unknown dito sa equation nito. So, pwede na natin isolve ang AY and that is negative. So, anong ibig sabihin? Downward yung support reaction sa AY. Bakit? Kasi negative ito. So, negative sign indicates that our assumption for the direction of AY was incorrect. So, ibig sabihin itong assumption natin na upward yung AY, nag-negative yung sagot natin, ibig sabihin downward siya. Okay, so we can now construct the shear diagram of the beam. So, nandito na yun. Itinama na natin yung correct direction ng reaction sa A. So, sa C, that is upward, clockwise, dun sa F, yung moment reaction, then upward yung vertical support reaction. Okay, so we can now find the ordinate at point A of our beam. So, that is just equal to this force. Kung ano man yung force dun sa left, extreme left ng beam, yun yung ordinate ng shear diagram natin dun sa point na yun. So that is negative. Why? Because the force is downward. Kaya ito negative. So pansinin niyo sa mga nauna natin sinolve, halos lahat is upward. No? Ito lang yata yung downward. So consider natin dapat yun yung side. That is negative 50. So since from point A to point B wala namang pagbabago yung load, constant din yung shear. So mananatili sa left point of point P, mayroon pa rin tayong negative 50 kN. So take note na concentrated load ito, kailangan natin isolve yung shear just to the left and just to the right of this point. This is point B. So just to the right of point B, guys, ito naman yun, ano, is equal to shear just to the left of point B. Itong negative 50 na ito. Yan. No? Then we subtract 200 kN. Bakit? Downward yung application ng load. So, pag sinolve natin, kuha natin yung negative 250 kN. That is the shear just to the right of point P. Then we solve the shear just to the left of point C. So since there's no change in load between B and C, constant pa rin. No? Walang pagbabago yung shear natin, ibig sabihin. So nananatili siyang negative 250 kN. Okay, so just to the right of point C, paano naman natin makompute yun? That is equal to shear just to the left of point C, which is negative 250 kN. Then we will add C1. Ano yan? Upward force. So, ibig sabihin, add ang gagamitin natin. Okay, so that is equal to 225 kN. Okay, so how about at point D and E? So, pwede naman natin yung compute, guys. Ano? That is just equal to 225 minus the area of this load. No? So, makukuha natin itong 75 kN. Pagka gusto naman natin compute yung shear at point A, so that is 75, subtract din natin yung area ng load between D and E, so 25 times 6 yun, kuha din natin ito 75 kN ito. Or, pwede rin natin gawin na 225 ito agad, no? That is shear to the right of C, no? Ito. Then, we will subtract the area of the whole load. Itong whole load na ito, 25 ang height, tapos ang length naman is 6 plus 6 plus 6, 80 meters. Ito yun. Okay, so that is equal to negative 225 kN. That is the shear just to the left of point F. No? So just to the right of point F, no? That is equal to shear just to the left of point F. Then we will add 225. That is the support reaction in vertical direction at point F. So upward yung direction ng support reaction na yan, kaya natin i-add to. So makukuha natin that is equal to 0. So ibig sabihin nag-close yung shear diagram natin, tama yung ating sagot. Okay? So dito na tayo sa moment. At point A, guys, no, moment at A is equal to 0. Since at point A, hinge yan, hindi siya magre-resist ng couple or moment reaction. Kaya 0 kagad dyan. Kapag roller yan, ganun din. No? So, sorry, dapat ito 0 nga ito dahil roller ito. No? So, wala tayong EX dyan dahil roller ito. Ang nandyan lang is A1. Okay, so, we continue. How about ordinate of moment diagram at point B? Paano naman natin makukuha yan? So that is just equal to the area of shear diagram between A and B. So since this is a negative shear, kailangan natin i-consider yung side negative. So makukuha nating ordinate is negative 150 kN meter. Paano naman yung ordinate dito sa point C ng moment diagram? So that is just equal to moment at point B. Then i-add natin uli yung area ng shear diagram between B and C. So ito yung area na yun ng shear diagram. So since this area is negative, consider din natin yung sign. So that is negative 150 moment at point B plus itong shear between B and C. Okay, so negative 250 times 3, kuha natin itong 900 kN meter negative 10. Okay, so at point D naman guys, paano natin makukuha yon? So that is equal to moment at point C, itong 900 kN meter na ito. Yan. So galing siya dito. Then, i-add natin yung area ng shear diagram between C and D. So itong trapezoidal area na ito. So nung ordinate, 225 at saka 75. So kukunin natin yung area, 225 plus 75, we multiply it by 6 yung distance from point C up to D, that is 6 meters, no? Then we divide by 2. So kuha natin yung ordinate ng moment at the location of hinge that is equal to 0. So nabanggit ko na ito guys, kapag mayroon tayong internal connection, dapat 0 ang makuha nating moment dyan lagi. So that is one way of checking kung tama yung sagot natin. Bakit? Kasi nga, nag-apply tayo dyan ng summation moment is equal to 0. Kung natatandaan ninyo, dito pa lang, summation moment at point D is equal to 0. No? So we take advantage about the internal hinge connection na yan, na 0 ang moment. Kaya dapat sa bending moment diagram natin, 0 ang makukuha nating ordinate dito. Okay, so next, how about the maximum moment? So maximum moment is being solved at the location of zero shear. So ang zero shear natin nandito sa midway between D and E. Kapag similar triangle ang kinuha natin, 225 ito, then 225 din ito, ibig sabihin, nandito siya sa gitna. No? So that is 3 meters to point D, 3 meters din siya sa point E. So that is equal to moment at point D, ito yon, plus the area of shear diagram between D and dito sa gitna na ito, no? Midway D and E. So that is equal to 75 multiplied by 3 all over 2. So that is maximum positive moment na tinatawag natin. That is 112.5 kilonewton meter. Okay, so paano naman natin makakuha yung moment at E? Dapat 0 din ito. Gaya nitong nakuha natin dito. So that is equal to maximum moment. That is 112.5. Kung ano man yung moment dito sa point of zero shear. Then, isusubtract natin itong area ng shear diagram between dito sa midway ng DE up to point E. Okay, so yung area na yun, ito yun. So negative, bakit? Negative kasi yung area. So kuha natin is 0. So tama yung sagot natin ulit. Alam natin, hinge yan dapat. 0 pa rin ang magiging ordinate ng moment diagram natin. Okay, so point E na tayo. So this is moment at point F, I should say, so I'm sorry. So itong moment at point E na ito that is equal to 0, ito yun. Then, we will add the area of the shear diagram between E and F. Itong negative area ng trapezoid na ito. That is 75 at saka 225. So, consider natin yung sign dun sa labas. Tapos gumamit tayo ng close and open parenthesis. We multiply by the distance, ito yung 6. Then we divide by 2, no? So, ito yung distance natin, 6. Para makuha natin yung area. So, kuha natin yung negative 900 kilonewton meter. So, that is equal to the moment reaction at point F. So, it will concave the beam downward at that point. So, ibig sabihin, nag-close yung bending moment diagram natin. Tama yung sagot natin. So, okay. So, that's it guys. Sa susunod, solve ulit tayo ng internally unstable beam.